Okay, so magnetic storage. This is also known as your HDD drives, your hard disk drives. If you take the case off, they look like this on the right hand side. Okay, so they're made up of these things called platters. So they're these disks, look a little bit like CDs. Okay, and they can spin very, very fast. So they can actually spin 7,200 times a second. Okay, which is ridiculously fast. Um, the read write head, which is this bit here, the read write head can move across that line there. So if you imagine the discs are spinning and the read write head can move side to side there, you can see how the read write head can cover the entire platter. And then you can see there's actually three platters there. So you can see the three platters. The spindle's just a bit in the middle. That's not that important. It's more the read write head and the platters that you need to understand. So it's a really, really common way of storing data. It's incredibly great value. But the downsides of them are the fact that there's moving parts has got two downsides. One, to access a piece of data over here, I might have to move the arm and spin the disk. Both of those two things take time, which makes this as a storage of memory slower than some other methods we have. The other downside is because there's got moving parts, there's more things that can break. So they're not as robust as some other styles of memory. Okay, if you imagine you've got one of these inside, let's say we put one inside a mobile phone, and a mobile phone you're carrying around, spinning it upside down all the time, stuff like that, that wouldn't be a very good storage method for data like that. On a sort of PC that's static, sat on a desk, it's a different ballgame. Or inside a laptop, they are commonly used in laptops as well, because they don't move as much. But they're not as robust as solid state drives, where there's no moving parts. So the way that data is stored on it is important to understand. So if we look at a platter, and we know there's multiple platters in a hard disk drive, if we actually look at it in this form here, you can start to see how that platter that's a circle is split up into sectors, and on each sector there are tracks. This is how you store data. The way it was described to me a long while ago, which is quite easy to remember, is imagine, it's obviously on a microscopic level, but imagine you sprinkled iron filings all over a platter. What you could then do is with your read write head, which is basically a magnet, I could change the polarity of the iron filings, and I could make them either north polarity or south polarity. And if you imagine a magnet's got two states, that's why it's good for representing binary. Because in binary, I could say everything that's north polarity is 1, everything that's south is a 0, or vice versa. Okay, so then if you imagine I've got iron filings stored on each of these tracks, as my magnet goes over these tracks, I can either change the polarity, which is writing to the platter, or I can read. I can use the magnet to read the polarity of the different sections, and therefore turn it back into ones and zeros. So that's kind of how a magnetic hard drive works. So the key facts are they can spin between 3,600, which is a slow one, up to about 12,500 revolutions a minute. They've got the actuator arm, which can change the polarity of the different sections of the platters. We've talked about the head of the arm, which does the job. We've talked about tracks and sectors. These platters can also be dual layer, so that means they can have a layer on the underside as well. Then it's non-volatile memory, so it doesn't require power. So because it's to do with magnetism, it doesn't require electricity. So therefore, when you turn the power off, the data will stay the same. And nowadays, these are relatively cheap. The downsides are the moving parts reduce the speed and durability, which, if you think of computers, speed is pretty much everything. So that's why nowadays you would be encouraged to buy an SSD drive instead of a HDD drive.